Hey 11s, we're now going to look at another example of working with logarithmic equations. Let's pick another two. Which ones look tough? I'll do F because there's a quadratic equation in there. You can try E yourself. And they all look pretty straightforward. Yeah, I don't know what to do. Maybe I'll do A just because there's a fraction. All right, here we go. Let's do a log base x of 1 on 25 is equal to -2. If I were to solve this, same thing. I would first probably change that 1 on 25 to 5 to the power of -2. Okay, and that's equal to -2 there. And then what I would do here is I want to get rid of logarithmic operation. So what's the inverse of log? It's exponential. In this case, it's base x. So I'm going to do exponential base x on the left and exponential base x on the right. So what that means is I'm going to say x to the power of log base x of 5 to the power of -2 is equal to x to the power of -2. See what I'm doing there? So by doing that, I know that the inverse, x to the power of log base x, are inverses one another, so they cancel out. This now becomes 5 to the power of -2 is equal to x to the power of -2. And look at that. What a happy coincidence. I now have a comparison to work with. Since both the equations are meant to equal to each other, this is a -2, that's a -2, so that means x must equal to 5. Look at that. That was an absolute lucky approach there. So I normally like to work with not fractions, and that's why I converted the 1 on 25 to 5 to the power of -2, and that happened to work in my favor there. Okay, so that's how I would do question A. I'm going to move this, make it a bit smaller, just so I can work with this space over here. So let's do F now. So in F, what do we have? We've got log base 3 of x squared minus 3x plus 1 is equal to 0. And same thing, I would try to get rid of that logarithmic base 3 by doing the inverse of log, which is exponential base 3. So I'm going to do exponential base 3 to the left, exponential base 3 to the right. And what that means is I'm doing 3 to the power of log base 3 of x squared minus 3x plus 1. And I'm doing 3 to the power of 0 on the right-hand side. Okay, so remember 3, exponential base 3 to the power of log base 3, they're inverses one another. They're going to cancel out. If you don't believe me, we can try it on our CAS right now. Let's try it on our CAS. So watch. I'm just going to clear all this out. And we did 3 to the power of, and I'm going to do log base 3, okay, x squared minus 3 times x plus 1. Watch. The 3, the exponential base 3, and the log base 3 are going to cancel out, and all I'm left with is x squared minus 3x plus 1. Can you see what I mean? So they're just inverses of one another. So all I did was just inverse the operation, and so that now gives me x squared minus 3x plus 1 is equal to 3 to the power of 0 is 1. Minus 1 on both sides, so I get now x squared minus 3x is equal to 0. Just to help you, minus 1, there you go. And so I'm balancing the equation, and now I'm going to factorize it. So take out x as a common factor, x minus 3. Use null factor law, so therefore x is either equal to 0 or x is equal to 3. Okay, so I'm just saying x could equal to 0, or maybe x minus 3 was equal to 0, and then you end up with x equals 3 or x equals 0. Okay? There you go. But can you have 0? Let me just think. Yeah, you can't have 0 because we know with logarithms or even exponentials, you can never have 3 to the power of anything to equal to 0. That's not possible. So yeah, actually, in that case, wait, where's x? Let me just double check. But it's okay for it to be 0 in this particular situation. No, it's okay. Yeah, the answer can be 0 and 3. So you can't have log 3 of 0 because that doesn't exist. 3 to the power of what will equal to 0? Nothing would work, right? But what I was looking at is in the equation itself, if x was 0, you'd end up with 0 squared minus 3 times 0 plus 1. That ends up being log base 3 of 1, and that's okay. So that, as long as that's not 0, it's okay to have. So these are the kind of things you gotta double check when you're answering questions in year 12 to check if both of them are possible, and I now know that both of them are okay. So there you go. Those are my two answers for 6A and 6F. Hopefully that gives you an idea of what to do. So have a look at my video for 4 and 6, but this is a really great exercise to get you practicing your logarithmic equations and skills.